Welcome back to Inside Factory Produce. Look closely at the horizon. From this sweeping drone perspective, it appears as though we are traversing a vast, silent mechanical graveyard. As far as the eye can see, millions of discarded electric vehicle battery packs are piled into metallic mountains, quietly waiting for their time to run out in these desolate fields. But beneath this rusted, heavy exterior lies a looming environmental crisis that the world is only just beginning to grasp, a phenomenon often referred to as white waste. As the global automotive industry shifts aggressively toward green energy and electrification, the sheer volume of expired lithium-ion batteries is becoming staggering. Industry analysts and environmental experts predict that by the year 2030, we will be facing an influx of over 10 million tons of battery waste annually. If left untreated in these open-air pits, these units could become ticking time bombs, leaking volatile organic compounds and toxic heavy metals into our precious soil and groundwater. However, in the high-tech corridors of modern industrialism, visionaries do not see a graveyard. They see what they call an artificial mine, or a black gold mine. Why? Because hidden inside these heavy-duty steel shells are some of the rarest, most strategically important, and expensive metals on the planet. Today, we are taking you behind the high-security gates of a state-of-the-art recycling facility. We will witness the incredible, high-heat transformation of hazardous waste into pure industrial treasure. This is a journey from the forgotten, dusty corners of the scrapyard to the brilliant, high-tech light of the sustainable future. Prepare to see the world of manufacturing like you have never seen it before. Every successful journey of industrial rebirth begins with absolute, uncompromising precision. As a massive, multi-kilogram battery pack enters the facility's intake bay, it is immediately greeted by a complex array of robotic sensors and automated logging systems. A high-speed laser scanner identifies the unique barcode and serial numbers, instantly retrieving the unit's entire life history, manufacturer data, and chemical DNA from a secure global database. Is it an NMC, nickel manganese cobalt, or an LFP, lithium iron phosphate? This distinction is vital, as each chemical profile requires a distinct, specialized processing route to ensure maximum material recovery and chemical purity. Before a single bolt can be turned or a single plate removed, we must address the most critical safety step of the entire process: electrical neutralization. Even though these batteries are classified as expired, spent, or dead, they often retain a residual electrical charge, known as stranded energy, strong enough to power a small residential home for days. If mishandled, this energy can cause a catastrophic thermal runaway event. Specialized automated hydraulic clamps connect to the main terminals, safely draining every last drop of this vampire energy. This recovered power isn't simply wasted, it is fed directly back into the facility's own microgrid to help run the very machines you see operating here. Once the unit is confirmed to be electrically cold and stable, heavy-duty robotic arms move in with surgical precision, thundering through the reinforced steel lids and exposing the thousands of individual cells arranged like a futuristic, glowing technological honeycomb. Thermal imaging cameras continuously scan the interior for hotspots, ensuring the environment remains 100% safe before we move into the mechanical heart of the plant. Now, we enter the most intense and physically demanding zone of the factory. To process thousands of individual battery cells every single hour, manual labor is simply out of the question. We enter the primary shredding chamber, a high-security, airtight vault filled with pure, pressurized nitrogen gas. We use nitrogen because oxygen is the fundamental fuel for fire. By removing it entirely from the atmosphere, we can tear into these high-energy batteries without the risk of an internal blaze or chemical explosion. Inside this dark, humming chamber, massive steel shafts equipped with interlocking, diamond-tipped teeth rotate with immense, bone-crushing torque. The sound is a rhythmic, overwhelming industrial symphony of cracking metal and tearing plastic as entire battery modules are reduced to tiny, uniform fragments in a matter of seconds. This is the critical stage of mechanical disintegration. Once shredded, the resulting debris falls onto a complex series of vibrating conveyor belts and magnetic separators. It looks like chaos to the untrained eye, but it is a highly controlled mechanical ballet. Overhead, massive electromagnets pulse with energy, yanking steel casing shards out of the mix with incredible force. High-velocity air jets then winnow the stream, blowing away lightweight plastic films and internal separators into dedicated collection bins. What remains on the belt is a glittering, colorful mixture of copper and aluminum flakes. But hidden beneath them is the ultimate prize of this process, the black mass. This fine, dark, shimmering powder is the concentrated essence of the battery, containing the lithium, cobalt, and nickel we came for. This powder is the true, black gold of the 21st century. And it is the foundation of the entire recycling economy. The journey now shifts from the world of heavy mechanical force and kinetic energy to the delicate, silent world of chemical alchemy. This advanced stage is known as hydrometallurgy. The raw black mass is transported into the specialized chemical wing of the factory, where it is fed into giant, gleaming stainless steel reaction vats filled with proprietary acid solutions. Within these massive tanks, a silent but violent molecular battle is taking place. As the acids break down the powder at a fundamental level, the solutions begin to bubble, hiss, and change colors in a vibrant, kaleidoscopic display of modern chemistry. Our expert laboratory technicians and chemical engineers monitor these reactions in real time using advanced sensors, adjusting temperatures and pH levels to the decimal point to ensure optimal separation. As the metals dissolve into the solution, we can begin the painstaking process of selective precipitation. That deep, sapphire blue liquid you see through the reinforced porthole is a nickel-rich solution. The radiant, glowing pink hue in the adjacent tank represents the cobalt being successfully isolated. Finally, a white, snow-like powder begins to settle at the bottom of the final tank. This is the high-value lithium carbonate. Using high-speed industrial centrifuges and advanced spray drying technology, these liquids are converted back into ultra-pure dry powders. Look at the quality of the final product. This material has reached a purity level of 99.9% or higher. This is no longer just recycled material, it is battery-grade chemical gold, ready to be reintroduced into the global supply chain and sold back to the world's leading technology manufacturers for the next generation of devices. These precious metallic powders are not destined for a storage warehouse shelf. They are already moving toward a brand new life. They are carefully packaged into vacuum-sealed, industrial-grade bags and shipped directly to the world's gigafactories and battery assembly plants. Here, the cycle of life begins anew in a spectacular display of manufacturing prowess. The recycled lithium, nickel, and cobalt are fed into high-precision industrial mixers to create a cathode paste. A process so incredibly delicate that even a single microscopic speck of dust could ruin the entire multi-million-dollar batch. Huge, high-speed rollers coat miles of ultra-thin aluminum foil with this dark, glossy material, which is then dried, compressed, cut, and wound into brand-new battery cells with nanometer precision. It is a staggering thought to consider. The very molecules of the battery in your brand-new electric car today might have lived a previous full life in a vehicle from a decade ago. This is the true, functional definition of a circular economy. By recycling these materials rather than mining them from the earth, we reduce the carbon footprint of battery production by over 70%. We are no longer just digging deeper holes in the Earth's crust. We are harvesting our own industrial past to power our collective future. Every new car that rolls off the assembly line with a recycled part is a major victory for sustainable engineering, resource management, and human ingenuity. As we fly back out over the factory complex, the sun sets on a facility that is doing so much more than just processing scrap metal. It is creating a lasting legacy for the next generation. The journey we have witnessed, from a toxic, forgotten scrapyard to a sleek, high-performance electric vehicle, is a testament to what happens when humanity stops seeing waste and starts seeing opportunity. Battery recycling is the fundamental cornerstone of the green revolution, ensuring that as we move toward a cleaner, electrified world, we do not leave a trail of environmental destruction behind us. Inside Factory Produce is incredibly proud to bring you these stories of profound industrial transformation and technological hope. Our future as a species isn't just about moving forward into the unknown, it's about moving in a perfect, sustainable circle, an infinite loop where nothing is truly lost, and every material has the potential to be reborn into something even better. The technology is here, the machines are ready and waiting, and the black gold is there to be claimed by those brave enough to innovate. So, the next time you see an old, discarded battery, remember the fire, the chemistry, the precision, and the rebirth you witnessed today. What role will you play in this grand circular future? Let us know your thoughts and visions in the comments below. And don't forget to like this video and subscribe for more deep dives into the world's most incredible and secretive factories. Until next time, remember, the future isn't just